All right. So far we've learned that the side with the minimum enthalpy is favored. So whatever reaction is exothermic. But this isn't the only thing that determines whether a reaction is going to be spontaneous or not. If it was an exclusive property, that means that all exothermic reactions would be spontaneous and all endothermic reactions would be non-spontaneous. And this isn't the case, right? There's spontaneous endothermic reactions and non-spontaneous exothermic reactions. Another piece of the puzzle is something called entropy. Now, this is a word that we haven't been introduced to yet. So enthalpy is the heat content of the system, and it's given by delta H. Entropy is a measure of the randomness of matter, and it's represented with a delta S. Entropy is talking about how, in a way, like how disorganized your matter is. There is a law, and I'm sure you've all experienced it, that things tend toward maximum entropy or disorder. This picture here is a good demonstration of maximum entropy, right? What's harder to do? Clean your room and keep it clean, or mess it up, right? It is so hard to keep things orderly. Life loves to explode. It's why we all have to stay on top of our house cleaning. Well, matter has the same rules. Everything prefers to be more random. The most random state is a gas. Gases have maximum entropy. They can just float wherever they want to go. Whereas if you think about a solid is held really tightly together and it's really nice and organized. So a solid has less randomness, meaning less entropy. A gas has more randomness, therefore more entropy. And if we wanted to look at an order here, we would say a solid has less entropy than a liquid, which has less entropy than an aqueous solution, which has less entropy than a gas. And you'll notice I use some double arrows between here because like gas is a lot more random than an aqueous solution, but an aqueous solution is only a little bit more random than a liquid, right? And then a liquid is a lot more random than a solid. So let's look at some scenarios here. When we talk about randomness, you're looking for the side containing the most particles of the most random phase, which is a really funny sentence to say, I think. So I've given you 3 scenarios here that we're going to talk through, and then I've got 3 reactions at the bottom that we have to decide which side has greater entropy. So in this first case, or in all of these cases, the entropy is going to be preferred in the products. Okay, so we're going to figure out why the products have more entropy. If you look at this first reaction, you have a solid state mixing with an aqueous state to form aqueous, gas, and liquid. The thing that tips this is the fact that a gas exists. As soon as you see that there is a gas on the right-hand side and no gas on the left-hand side, you know that you have the most particles in the most random phase on the product side of the reaction. So that one's a pretty easy one. If there's a gas and no gases anywhere else, favor that side. The next scenario is, what if we have gases on both sides of my reaction? Well, then what we do is we count up the moles of gas on each side. So if you look at this one, we have 4 moles of this NH3 and we have 5 moles of the O2, which means on the left-hand side, so the left side has 9 moles of gas, whereas the right side has 4 plus 6, which is going to give us 10 moles of gas. Therefore, the right side has more moles of gas. It has more particles in the most random phase. The last example here is a substance dissolved in water. So if you look at this one, we have a solid on the left, but we have an aqueous on the right. So it's the same explanation. We're not involving a gas, but we are saying that the aqueous state on the right has greater entropy than the solid state on the left. Right? Okay, so here's 3 examples. Like, I want you to pause the video and see if you can answer which side has greater entropy, reactants or products. So this first one, we're looking aqueous. So this one would be products. For this next one, we've got 2 moles of gas on the left. We have 4 moles of gas on the right. So the products again. And then lastly, we have a gas on the left, no gases on the right. So my reactants would have more entropy. All right, go practice those.